what we have here is the question B, the question second of the Codeforces round that was conducted today, and the question statement states starts with some sentence, and then it says that it is no surprise that Fiscal speaks with such a strange choice of words, but this time not even Oz, her raven friend, can interpret her expressions. Maybe you can help us understand what this young princess is saying. So what we are given is a string of n lowercase Latin letters and the word that Fiscal just spoke. So we can think of max of a string that so this must be a property of each string. So of a string that helps us to find the meaning behind the message. So this property max is defined as a shortest string that doesn't appear in the contiguous substring in the input. If multiple strings exist, the lexicographically smallest one is considered the max. Note that the empty substring does not count as a valid max. So basically, for an example, what we can say is that basically if we had the string A, B, C, the MEX of this would be D. The MEX value, the MEX property of this string would be D because D is the smallest string, that is lengthwise smallest string, and also the lexicographically smallest string that does not occur in this array. So basically A, we start counting from A, then B, then C, then we check if D is there in this array or not, and if it's not there, we output. So, but also in some cases, let us say we have all the elements from A, B, C till until Z, and also after that we have what we have are the elements AA, AB. So basically we started counting from A, B, C, D, but up till Z we have all the numbers, all the letters. So basically we will now start with the strings of length 2. So basically we see we have AA and AB, but no, we don't have any string AC as a segment of the given string. So basically in this case the output will be AC. So this is for the property max of this, and so the string A is lexicographically smaller than this. This is just like definition of lexicographically smaller, and you can read this on your own. And string A is a substring of string B if A can be obtained from. So this substring is a contiguous substring. So it must start an index in A and end at an index in A after that, and the length of this must be greater than or equal to 1. So what we need to find is just the max of the string. So basically, we will given the length of the string and then the string itself, and we need to find the max. So what we see in this case, as you can see, the length of input, the length of any string is limited to 1000. What we can say is that let us see this is the length, and this is the number. So this is num and this is length. So basically for length 1, for strings of length 1, we have 26, that is from A to Z. A to Z. We have 26 letters, and for length 2 we have basically we have 26 into 26. So that is from AA to ZZ. So we go from AA to AB and until AZ, then from BA to BB, BC, and until BZ, and so on till ZZ. So basically, this is what we have. And for 3, we have 26 power 3. So we have 26 power 3 for length 3. So basically, we go from triple A to triple Z. And what we see here, then that the number over here is 26, and the number over here is 576, and the number over here is 576 into 26. So basically this can occur. Yes, this number 26 characters are possible in an string of length 1000, and also what we can see is that for number 576 we can have some, at least some, like we can have 500 what you can say is we can have 500 of this 576. So A, B, and so on. And we may have 576. Yes, so possibly, but I haven't tested that if we have 576 and in any case. But after that, this is the limit for that. So 576 into 26 can be set as the limit, and this would be a safe limit for any case. So basically, what we can see is that as the length of the input array is limited to 1000, so the output of the property max will be at most uh, a string of length 3. So basically we will have the result as a string of length 1 or 2 or 3. So for so as you can see, now we can check for all the strings of length 1, then of length 2, and then of length 3 also. Because for a computer, checking this will be easy, because 26 plus 576 plus 576 into 26 won't be greater than 15,000 operations or 15,000 slots of memory, and which is really small for any program. So basically the code is also really simple of this. And what you can see here is that I just take the input string for this, and then I declare some arrays. So this is the array for the starting, for the strings of length 1. So I just iterate over all the characters of this, and see, and for each character I just add 1 to the initial value of 0, and if the value for any of from 1 to 26 for any character is equal to 0, I just return the property of max, and after that I return the function. And if this loop does not return any possible value of mex, so then I go on to checking the strings of length 2. This can be done by this by using this array, and after that I just use the properties that the second element can have a maximum value of 25, that is from 0 1 2 3 to 20 to 25. And the first element can then be just multiplication of 26 multiplied by the element itself, that is the difference of that with the integer value of a, and then adding 1 with that multiply with 26. So basically this will yield that. And after that we can do this. After that similarly we iterate and see if any element has a 0 in that, and after that we can have the output for the similarly, if this does not return any output, then we can have the output return for the strings of length 3, which can be done by similar method as we did for the same string of length 2. In this case, we will go on to add 576 multiplied by that answer. So basically, this is what we will get, and after that, this possibly is the correct solution. And what you can see over here is that my submissions. So basically this question, this is the summation I made, and so you can see here, and this is the as the system is right now testing. So basically I cannot see if this verdict is correct, but the pretest passed, so that's an assurance. Thank you.